All right, while we're finishing up waiting, y'all can write these down. I tried to get them as big as possible. I don't want to blow them up too big. But there you go. These are pretty much the rules that you're going to be using for polar coordinates. And as you can see with the derivative and the antiderivative, you're going to be plugging in things. You're going to be taking derivatives of other things and plugging it in. You're seeing the same type of methodology in this unit, because we're making the transfer over from calculus 2 to a little bit of calculus 3. The plugging and chugging of antiderivatives and into the plugging and chugging of derivatives into other equations or formulas to find the antiderivative or the derivative. Now the 3 or 4, yeah, just come on in whenever, that's fine. These right here are just your basic algebra and trig formulas for polar coordinates. Now polar coordinates, I don't know why they call them polar coordinates, but they're basically vectors. That's what they are. And I think they're also trying to get you to understand vectors a little bit more. So I think if you write down all of these, you'll have pretty much whatever chapter we're in, 10.3 and 10.4. I think you'll have 10.3 and 10.4 down. The good thing is 10.5 and 10.6 is not that big of a deal because it's kind of a review over parabolas. And we'll cover those Tuesday. So you're talking about a test probably opening up next week. It's not going to be a very hard test. It ain't going to be like the first 3 tests where you were learning new stuff. This is taking the stuff that you've learned and plugging and chugging. Now that bottle you got right there looks like a bottle of vodka or moonshine. Why does it have a funky bottle? Is that just the way it comes?
No, this is just water. It's just something I just like to drink out of glass, so I'm not going to use this thing.
Oh, okay.
It is all good.
I've heard a lot of people are starting to drink more out of glass.
Yeah.
I don't know why we ever stopped.
Well, the BPA leaches into the water, and BPA is going to cause birth defects.
What's BPA?
It's a byproduct from the
plastics. I get it.
Bisphenol, something.
Well, I think Coca-Cola is best served out of glass bottles. I've always said that. Well, anyway, you've got 3 sections in this unit. The first section is parametric equations, and we did that plugging and chugging into the fraction. And then you've got 2 sections of polar coordinates, and then you got 2 sections of parabolas and hyperbolas. So it's kind of like you're getting 3 little sections into this unit. And again, I don't think it's difficult because all you're doing is taking what you've learned and plugging it in. So I don't think it's versus an introduction to something new like integration by parts or trig substitution. This is something that you basically know how to do it. You just find the new formulas to plug it into. Now I'm going to go over a little review of polar coordinates because I don't know how long it's been since some of y'all have had polar coordinates. I know we went over it a little bit in Calc 1, didn't we? My class, didn't we go over it? I think we went over it a little bit. Somebody let me know if I did or didn't. But most of you have had polar coordinates because you've had physics. Some of you are taking physics. And physics and polar coordinates fit right hand in hand. But I'm going to go over a little bit of review. Hopefully everybody's got this. I'm going to go over a little bit of review of polar coordinates, just in case we've got a couple of people that haven't had Calc 1 in a while. Make the transition over from the Cartesian coordinate system. And Cartesian coordinate system is what nobody calls it. Basically, the Cartesian coordinate system is called what? Rectangular. Because everything pretty much looks like a rectangle as far as building it, if that's spelled right. Let's say you got a point here and here, that's X and Y. Well, in rectangular, you just have an X and a Y, whereas in polar, you have a angle and a direction and magnitude. Now, of course, you don't call it direction and magnitude, that's in vectors, but if you have this same point, take a red line and draw a line to this same point. You have a theta and you have R. So a rectangular coordinate can be written as a polar coordinate, and a polar coordinate can be written as a rectangular coordinate. And polar coordinates, you have an angle and you have a distance or a magnitude. I'm going to call it magnitude because that's basically what you're going to be calling it in vectors. Now, the only thing that I would stress in review of polar coordinates is that you can have multiple descriptions of a point with polar coordinates. In other words, with this X and Y, that's just one point. You have an X and a Y to that one point. But you can also have another description with polar coordinates because of the, if I have this line right here, this is the negative R of this, and of course the angle would be the same because it's an extension of this here. So I could go, if this was, let's say this was -2 and this was +2, I could rewrite this point right here as theta comma -4 or 4, -4. Yeah. No. Theta going this way, 4, back -4. I could write it something like that right there. Which would mean, go back down here, theta, and then back to -4, I could rewrite that point. So, basically, I want you to remember that polar coordinates can be written different ways. I've got an example here in just a minute. That's one of the things I'd like for you to kind of highlight, because with the negative and the theta, you can write them different ways. I hope I've got it in here. Yeah, okay. So I got kind of 3 examples, kind of refresh your memory. One is 1, comma, pi over 2. D, or the second one, is -2 pi over 4. And the third one is -1 pi over 2. So what I want you to do is I want you to plot those through. Okay, y'all see that eraser work. Let's see how long it works. -2 pi over 4. Draw you a grid and draw those three, just kind of a review. We're going to go over these quickly so we can get to the derivative and antiderivative and maybe to the part one. I'm going to draw these on the same thing, so I'm going to erase this if y'all don't mind. How many of y'all remember polar coordinates? Anybody want to speak up? Did I go over them in Calc 1? I'm sorry, what? I can't hear you. Your voice is gone. In trivia. All right, so pi over 2 would be what? 90 degrees? So pi over 2, I'm going to draw it in red. Pi over 2 would be 90 degrees. And 1 unit up. And there is the polar coordinate right there. That seems simple enough. -2 and pi over, I'll do it in blue. Let me draw my pi over 4. What is pi over 4? .45 degrees. So, and I'm just going to draw a line and put pi over 2 right here. And I'm going to draw a line here because we have if positive 2 is right here, then what? Pi over 4. Pi over 4 is 45 degrees, isn't it?
Yeah. Yeah, you're drawing it 45 degrees.
Yeah.
Pi over 2.
Huh?
You want pi over 2.
Oh, I'm sorry. I didn't know what you were talking about. I'm sorry. Thank you. All right, so this is 2, so -2 would be this way. So the actual polar coordinate is right there. Okay, so again, you got to watch this because I don't want you to mess up when you do the polar coordinates because of the -2. Now, the third one, watch what happens with the third one. Well, what is -pi over 2? What is -pi over 2? That's this way. So I'm going to do another color. I'm going to do a green color. And -pi over 2 is this way. And then it wants to go -1, but this, since this direction is going this way, this is +1. And if I go back this way, I end up, hold on, I think I've put something down wrong. Yeah, this way is +1, so this way would be what? -1. So this point right here can be written as the first one, which was 1π/2, or it can be written as -1 π/2. So you got to be careful when you're doing these polar coordinates, especially when you see a negative. And it's all about the angle first. Always draw your angle first, and that's something you need to write down, because angle first. And that's not a rule of mathematics. That's just something that kind of helped me when I was a student working with polar coordinates and vectors. It's kind of helpful to draw the angle first and let the magnitude fall where it falls. Okay? Now, what if you're given polar and you're asked to write it in rectangular? And we'll see how much y'all remember. I'm going to let y'all do this one. Some of y'all probably get it right off the bat. And some of y'all will sit there and just stare at it. Right? No, not y'all. So interactive this morning. Mr. Huff, you remember this stuff? He's already gone back to sleep. He's hung over this morning probably. So he won't even talk to me. Huh? No, he threw his dog out. That's where they should be.
He says he's not asleep, he's in a tunnel, remember?
Huh?
He says he's not asleep, he's in a tunnel, remember?
Oh yeah, that's right. He can't talk. Needs one of these super duper microphones. They spent like, they're going to tell how much money they spent on this thing, and nobody uses it. Because it's so dadgum loud.
Man, I would love that kind of stuff. When I expect the review, I put on the projector and put on the surround sound, sit on the couch. I think it's loud. If you get loud, it gets really loud.
Yeah. Where's Mr. Whizenhunt? Where are you at? He's not going to talk to me either. Okay. You finished already? This sheet is like, I'm here, but I'm not here.
Maybe you can't hear them. This I said, I guess you can't hear me.
Well, the dadgum volume is up.
That's the microphone volume.
Oh, Lord. Nothing's muted. Speakers are at 92%. All the microphones. It's Russia's fault. Yeah, Mr. Whizenhunt. It says your microphone is muted, Mr. Whizenhunt. In which all of your microphones should be muted so I don't hear no freaking dog barking in the background. Why are you logged on when you're here?
Because then I can take screenshots rather than take pictures.
Oh. Okay. Well, will somebody interact with me? Because my class won't interact with me except for Annabelle. She interacts with me. But is anybody remembering how to do polar coordinates or forgotten how to do polar coordinates? How is a teacher supposed to teach when nobody talks to them? What? Well, I'm not that type. I like to interact. Y'all suck. Just kidding. Well, Annabelle, I guess we'll just keep on going. Nobody's going to talk to me. Thank you, Mr. Wisenhunt, for at least messaging me. Yeah, I was getting some kicks. God, them things are awful. Like eating Cheerios, like eating little pieces of cardboard. All right, we get back to work since y'all finished. Well, 2 times square root of 2 is 2.82. So that's pretty simple. 3 pi over 4, what's that? Okay. No interaction. I'll just draw a dadgum graph. And what is it, like 3 pi over 4, 180 over pi. Let's see, pi's cancel, 4 will go into 180. How many times? 4 will go into 180. 45. 45 times 3 is what? 135. Somebody help me out. 135 is going to be, I'm going to do it in red. Somewhere in there. So theta is equal to 135. Now, why did I say 135? I said because no one walks on a construction site and speaks in terms of pi. Nobody. And 2.82, I'll just draw it like this, maybe right there. And we'll call this 1, 2, 3. 1, 2, 3.
Why did they teach you about pi when you just not know that?
Because it's academic. It's academia, that's why. And most of your academic teachers have never lived out in the real world, and I mean this with all sincerity. When I was in civil engineering, I had engineering teachers that never set foot on a construction site. They're called professional students. Y'all ever heard that term before?
I've seen that. I had a teacher the other day and I said, "Is that something with particle board?" She said, "What's that?" And I was holding it. She said, "Is that particle board?" I said, "Yeah."
Yeah.
Oh.
So you have books and mathematicians that have never been out in the real world, and they don't know that if you walk on a construction site and say, yeah, we need to turn 3 pi over 4 and go 252 feet instead of state, they have no idea that that's not the way it's done. It's kind of like, I told y'all about the guy with the tire. I went and got a tire fix last week on my mama's car, and there was a guy there who was about 25 years old that pulled up in some little car, and it's like 75 degrees outside, and he's got a big old stocking cap on his head with hair sticking everywhere. He looked like a freaking idiot. But anyway, he's a deadhead. So he's got this tire, and he says this tire keeps going down. And I was told to come here. I'm standing there waiting on my tire, and I just He pulled up right where I was standing. And the guy looks and he said, "You got a nail in your tire. Did you know you got a nail in your tire?" And the tire is a roofing nail. And you know, a roofing nail has a head on it that's about that big around. And it's been hitting the asphalt. So what happens when the nail hits the asphalt a bunch of times? It's real shiny. So he's got a big shiny disc in his dadgum tire. No. What do I do about it? He didn't know it could be fixed. He had no clue. Now, I'll tell you that story because you have teachers that are teaching subject area that have never been out in the real world. So that's why you're still getting 3.4. In a construction management class or a surveying class or a traffic engineering class, you're never going to see 3.4. You're going to see degrees because those are practical applications. All right, I'll shut up now. And that's this is. I'm going to call it 2 square root of 2 because of the square. All you have to do now is what? Change it into. This is not the scale. I'm just drawing it, so these hash marks may be off. You got to get your X and your Y. You really don't need this one, but. Okay, when did I change it over to? I'm sorry, what did you say? Yeah, exactly. All right, so what do you do?
How do you find the other angles?
How do you do it?
You do your trade. You know the degrees of it. You could use the environmental apply. See, do you set tone?
Nope. What can you do? Okay, I'm asking Skype people too. Okay, somebody needs to remember. There's always one person that remembers how to do this. R sine theta, R cosine theta. X is equal to R cosine theta. And Y is equal to what? R sine theta. So you were partly right, Annabelle. I watched 2 more scary movies last night.
Wow, Lee, you're on that.
Oh, I love to watch. I watch them. I've done watch since I got that Fire Stick. I bet I've watched 50, not 50, but probably 25 movies.
Did you know that what you watch is a corner into
Yeah. Yeah, I always go to old houses where there's no cell phone service, and I have no gun. Always. And I always go into dark rooms that I know nothing about.
Hey, we saw a good movie last night.
What was it?
It has a scary name, but it actually is a really good movie. It's called The Shack.
Yeah, I've heard. It's a good movie.
It is a good movie. It's, it's not for religious people.
Mm-hmm.
Because religious people will
Find something wrong with it.
Can't get out of the box.
Yep.
Yeah.
All right, so somebody crank those out. What do you get? It means you got to get your calculators out. You actually got to punch, and y'all do that. See, Mr. Edwards is going to call my boss right now and tell him I got alcohol. There's that. Sorry. So that point, if you were writing it in the Cartesian coordinate system, would be 2 and negative 2. Just don't look at my marks. My marks should be different, and I can't erase it. So 1, 2, 1, 2. So it's a 2 and negative 2. Okay. And make sure you can go the other way. No sneezing, please. What time did you get home last night? Or this morning? No, it wasn't too bad. Where were they playing? Huh? Oh. Well, that wasn't bad at all. Then. All right, this is a rectangular coordinate. And you need to plot it and change it to polar coordinates. I watched Life the other night. It's about a space crew on a space station. An organism takes over the space station. It's pretty good.
Oh, that's a good one. Yeah. I saw
And it wasn't in Russian or Japanese either. It was pretty good. But you could tell somebody recorded it from their cell phone.
But you watch it on?
Fire Stick. My Fire Stick, my Amazon Fire Stick.
So you download yours too?
I'm sorry, what?
You download your Fire Stick too?
Yeah, I sent it to somebody. Yeah, and I've watched all the latest horror movies. Now I'm watching all the stupid horror movies. You know, you have the bad actors and the stupid plots. And
I saw this movie called I Organs. That was just the letter I, Organs.
is it scary?
But,
I even got the scary movie Jeopardy question right, Final Jeopardy question right yesterday. This movie was remade in 2006, was debuted, remade and showed on 6/6/2006, 30 years after its original. Oh.
I remember 6/6/2006. Everyone was scared.
You know, Bunny on Platoon has a real good philosophy of life. Oh, yeah. And that is, when you die, you ain't gonna know it. And these people are scared of this and scared of that. When it's your time to go, there's nothing gonna stop it.
But you know, when some people that have the horrible deaths, there's people that that have had near-death experiences, and you're talking to people and saying that pray that they're going to die.
Yeah.
They're not even worried about it.
Well, he says that in the movie Platoon. Some of y'all probably never seen it. Anyway, and that's you're gonna be dead, and that's okay because you ain't gonna know it anyway. The black guy that's with it said, "Man, I gotta be in a fighting hole with you." Anyway, I don't think it's funny. Y'all know what I did. All right, rectangular coordinate of -1 and negative square root of 3. The square root of 3 is what? 1.7. Somebody check it for 1.57, 1.6. So negative 1 and negative 1.57. Or 1.7. I don't have graphs. I don't have graduations on mine, so. So there's my polar coordinate. Or there's my Cartesian coordinate. Now what do you got to do to find your polar coordinate? Well, you've got x and y. So you just plug it in the Pythagorean theorem. Negative 1 squared plus negative square root of 3 squared is equal to r squared. Dang old r is equal to the square root of 4. R is equal to what? 2. Now, remember, you've got tangent of theta is equal to what? Y over x. Look at your formula sheet. So, theta is equal to the inverse tangent of what? Negative square root of 3 over negative 1. And somebody tell me what that comes out to be. I'm sorry, what? Well, it'd be 60 degrees, it'd be negative 60 degrees, which would be what? Be 60 plus 180. What's it, 240? Is that right? 240. 240 degrees. Huh? What did you plug in? Negative over negative? Well, the reference angle is 60 degrees right here, but it's around this way, so 60 degrees would be 60 plus 180, which is 240. But you could say 60 degrees or pi over what? Whatever it comes out to be. I don't worry about that pi over crap. When you grow up using degrees all your life, it's hard to learn pi over 6 and pi over 4. It really is. It's almost impossible. That's why I have to put it through the conversion in my head. I have to convert it. Now I want you to get your graphing calculators out. I want you to switch it over to polar, and I want you to graph a few things. Graph whatever you want to. That was from rectangular to polar. So take your handy dandy calculator and switch over to polar. And then graph something. And graph whatever you want to. Graph r sub 1 is equal to 1. And r sub 2 is equal to 2. Dang old get a donut. Graph just one. Now this section of whatever section we're in, 10.3, this section they're going to tell you, I want you to read about doing the, I'm trying to find something to talk at the same time. Hold on a minute. I can't do it very well. 3 cosine. Do 3 cosine of theta. This section of 10.3 and the homework section of 10.3, I just want you to use your graphing calculator, okay? I don't want you to have to try to plot it. Read about it in the book, but there's no sense in trying to plot it. So what did I say? Graph next?
You said R1, R2. I did that, and I kept doing zoom and fit, and zoom out, and zoom out, and zoom out, and it seems like it's just way too big.
We'll just do zoom fit. Zoom 0.
That's what I'm doing, zoom 0.
Well, then you got something wrong. There, look. That's zoom fit. Have you got it on polar?
Yes. See, that's what it looks like. It's right here and here.
Yeah, she's got it in degree and polar.
Oh.
Thank you, Michelle. All right, now what did I say do? Y is equal to what? 3 cosine zoom no, I don't want that. Zoom standard. Okay. And that's what that looks like. And here's another example of one you might see on the homework or the test. Graph when R is between -1 and 1, and theta is between pi over 4 and 3 pi over 4. Graph that right quick, not on your calculator, by hand. Because you got to use your brain on this one. And this is just a section to help you remember how to graph polar coordinates. You want to retrieve what? Oh, okay. Retrieve the pencil. Oh, I thought she said tree pencils. I didn't know what she was talking about. So what kind of shape you come up with? What? Okay, the top is an arc and the bottom is an arc. It should be like an hourglass. What do you do first? The magnitude or the direction? The direction. What's pi over 4? 45? So I'm going to just draw a dashed line and a dashed line there. And then 3 pi over 4 is right here and right here. And my radius is 1. So here and there. Now, I want you to write R is equal to 2. That's a circle. And I want you to turn it into a rectangular coordinate equation. Not from memory. I want you to do it from using the conversion formulas. The 4 that was in the top left-hand corner, the 4 r sine theta, r cosine theta, x squared plus y squared is equal to r squared, and what's the last one? Tangent is equal to y over x. You got to use one of them. Actually, it just takes 2 or 3 steps. It's not that difficult. I'll get Mr. Huss to explain it as soon as y'all get finished. Or Mr. Whistlehunt, one of them. Okay. I did that one time to a smart aleck in class that knew everything. You ever met one of those people? And I told him, I said, I tell you what, you're so vocal, come on up here in my second or third semester. He had on one of them gray shirts, like an athletic shirt, like a gym shirt, a gray tight shirt. He got up here and started stuttering. And then after he started stuttering, that gray shirt started turning dark gray. He started sweating profusely. I didn't have any more problems after that. And he got the problem wrong on the board. He never did say a word after that. I didn't know all that was going to happen. I'm so mean. 2 is equal to, or 2 squared is equal to x squared plus y squared. And 4 is equal to x squared plus y squared. So whenever you see x squared plus y squared is equal to a number, you know it's going to be some form of what? Circle. Because r is equal to 2 means that wherever there's a 2, there's going to be a what? A point. All right, let me give you another one you might see. And this is just trig and algebra. R is equal to, you don't have to draw this one. Just have to tangent of theta, secant of theta. Change that into a rectangular equation. Now this one might be a little bit challenging. You will use reciprocal identities. Y'all pretty much gonna suck at this, right? Are the Skype people awake, Annabelle?
Yes.
Okay. Ma'am? You don't know what? I don't either. Except Annabelle. And that's why she said like 15 classes with me.
get rid of them. You know, I really wish you could teach that fully.
I wish I could too.
I'm really upset about that. I need you.
Did you write an email?
Yes.
Good. No, the reason they don't want to teach it here is they want the guy up at the full-time guy up at Penalty to teach it. And if I taught it here, everybody would come here.
But you're full-time.
Yeah.
This is the middle of campus anyway.
I know. You preaching to the choir here. All right. So y'all give up yet? What is a tangent? Reciprocal identity for tangent. Sine over what? What's secant? What's the rule about writing identities as other things? Always go to the what? Sine and what? Always try to go to the sine and cosine. And that gives us sine over cosine squared theta. And now I've got a fraction, so I'm going to multiply by cosine squared. Well, that's not going to help me very much, but I'm starting to see r cosine. So if I multiply it by r on both sides, I might be able to get something to work. So that's going to give me r squared cosine squared equals r sine theta. Now work with that. See what you can do there. Hopefully you should start seeing it. If not, then mathematically you're a failure. Algebraically you're a failure. Do you at least see why? Huh? No. Do you see why in the equation? Yeah. Yeah, why are y'all a failure? Because you're in Hubert's class. That's why you need to be in the better teacher's class. R sine theta is equal to what? Okay. I can rewrite this as r cosine theta quantity what? And what's r cosine theta? X. So y is equal to what? Y is equal to x squared. You're supposed to think that's neat. Yep, I figured you'd like that. All right, here's something to try. Is equal to 0, not theta. Oh, come on. All right, that's a polar equation graphic. Actually, you already graphed it, but you got to solve it algebraically first. Somebody tell me what you get as soon as you do it. What does the graph look like? Huh? The donut. Yes, it looks like the donut.
Are we supposed to bring 3r plus 2 to the other side? Make it like x squared plus y, or equals y? And y is 3r minus 2?
What do you do with a trinomial? Always. What do you do with a trinomial? No. What do you do with the trinomials? Pick up.
I don't know.
I failed. Factor. And when you graph that, you get what? You get the donut. Okay, so the first part of 10.3 is what I just covered. Okay, so some of your homework problems on 10.3 will be some of these. Kind of a review. Now, write down the antiderivative, which is the area in a polar coordinate or a polar graph. Write it down on your section notes that you are on right now. I'm not going to write it on, well, I'll write it on the board in front of this problem. Area of a polar graph, I'm just going to put PG, is equal to A to B 1/2 F of theta quantity squared d theta. And you can pull the 1/2 out. Yeah, I thought I said squared, didn't I? I thought I did. And the problem I'm going to give you is R is equal to sine of 4 theta. You're going to use an identity for the sine squared of 4 theta. And it's not going to be, it's one of those half angle identities. So you might have to revert back to your half angle cheat sheet that I gave y'all for the one person that kept it. This sheet. Everybody else threw it away.
Well, wasn't here.
Huh? Or wasn't here, yeah.
Yeah, that's I have problems with that on the homework, and I was talking about my friends with it. And I just don't get how x squared is equal to, just the roll over and how they would make that. It's just, that's what.
You get it from the derivation. It all derives from the Pythagorean theorem. Just like right now we're using tangent theta is equal to x over y. It all goes back to the Pythagorean theorem.
Actually, I do substitute and homework and stuff there. Every first problem and stuff like that. Everyone's just staring at how is that really what I'm supposed to do.
Why don't you ask me and I'll go over to the next class?
Because I'm not here usually.
Well, I would do it on the board and record it. I mean, don't sit at home. No, don't do that. That's what I'm here for. That's an insult to me. Asking somebody else. Because let's see, sine squared of 4 theta d theta. A is equal to 1/2 A to B of 1/2 1 minus cosine 8 theta d theta. And we're going to do this in the first quadrant, or the 0 to the power of 4. I'm about to give you that. 0 to the power of 4. All right, I'll take the antiderivative of that. Well, the 1/2 can come out. A is equal to 1/4 bracket theta minus sine of 8 theta over 8 evaluated, well, inside the brackets, evaluated at 0 and pi over 4. Now, plug and chug. See what you get. Y'all know what that means, right? You know how to do it. I got pi over 16, I think. Because you do pi over 4, I think. Look and see if you do pi over 4 and you times 1/4 is pi over 16, I think. So that'd be what? 0.2 pi over 16. Or, I'm sorry, that's yeah. 0.2. So what's the only thing new here? The only thing new here is what? The formula. Who's got a question on that? Now make sure you have your identity cheat sheet because you're going to need it or print you one out. Just go to Google and put trig identities, and there's a green one on there I use all the time. It's green and white, or it's white paper with green splotches on it, or green boxes on it. All right, that's the antiderivative. Now find the tangent, the slope of the tangent at r is equal to 4. Find slope tangent at r is equal to 4 and theta is equal to pi over 4. So you got to use your formula, and that's the derivative formula that I've shared with you at the beginning of the class. I'm trying to find it. There it is. Go to it. Do not plug in theta until you get everything, until you get the derivative. That's a mistake some students do. They try to plug in theta. You don't plug in theta till the very end of your derivative. He's doing fine. I have him today. I got to go get him. I have him one day every other week, and every other week I have him. So one day a week, and then next week I'll have him the whole week. She has him one day next week.
I heard this thing on the radio about this 8 or 9-year-old boy who stole his dad's van to go to McDonald's with his 4-year-old sister. And he got to McDonald's and got something and came back. And the police say he didn't buy like any traffic violations.
How old is he?
8 or 9, just small.
Well, my son can drive anything on the farm.
They said, how do you know how to drive? He said, I watch YouTube videos.
Well, my son can operate any piece of equipment on the farm.
What's that?
Oh, yep. He can even run the bulldozers and the tractor.
You pay him in SpongeBob episodes.
Yep. No, actually, I paid him by buying him stuff. I bought him a bunch of work shirts and some. He wanted a pair of cowboy boots. I got a pair of work. They look like cowboy boots, but they don't look like real cowboy boots, but they're work boots. And he wanted a pair like that. They're pretty expensive because they're waterproof and there's leather. And he wanted a pair, so I bought him a pair. They're supposed to be here today, I think.
My dad did that to me once.
Yeah. Now they're twice that much.
Oh, really?
Yeah. I got them off of Amazon about $30 cheaper. Because he did the Rockies. So, plug and chug. So we got d theta, I can't see. dr d theta. What is dr d theta? What's the derivative of pi over 4? 0, Hubert. That's right. So, 0 dy dx is equal to 0 times sine of theta plus 4 cosine of theta over 0 cosine of theta minus 4 sine of theta. And what happens to the first part? What happens to these? Well, they go away. They go to 0. Everybody should be saying that. Why are y'all not saying that? One person. Y'all suck. So we get 4 cosine of theta over negative 4 sine of theta. And 4's go out. So you're left with cosine of theta over sine of theta. And that is the derivative. That is the slope, the equation of the slope of the tangent line D point on this curve. No. Well, that goes back to your first rule of identities. Always put it in the form of what? Okay, at evaluate at pi over 4. So for the next part, this is your setup, this is your derivative. So evaluated at pi over 4, cosine of pi over 4 divided by the sine of pi over 4, and that's your answer, which comes out, I think, to be -1. I got a couple more examples, but I'd like to get to the length of the curve, just so I can have that under your belt. And then we'll work on some examples more on Tuesday. Length of the curve is equal to A to B, the square root of r squared plus dr d theta quantity squared d theta. Now that can also be written as r squared plus r prime. Let's look for that. Is that what, did I give you both of them? Yes, Hubert. No, Hubert. I don't know, Hubert. Did I give you both formulas? I thought I gave y'all 2 formulas for the length. Find the length on half of a cardioid from 0 to pi. And r prime is equal to negative sine theta. You should have that. So plug and chug. Do your algebra. Now, for some of y'all, this is a transition type unit. Remember me telling you references to Calc 3? Well, we're fixing, what you're fixing to do, that's a cardioid. If you notice anything, you're starting to find points on a more circular curve than before. Before you were finding points on a parabola, finding tangent when we first started calculus. Now you're finding points on a more circular curve. Eventually, you're going to make the transition into three-dimensional space. And then you'll be doing on a three-dimensional curve, which throws in the z variable, x, y, and z. That's why I gave you all that picture of the cardioid with tangents on it. Because you're starting to incorporate the derivatives and the antiderivatives to find the three-dimensional vectors in Calc 3. No, you're so smart, dude. All right, so we've got, basically, I'm not going to do the antiderivative yet. 1 plus cosine theta squared plus parentheses negative, what it might be, negative sine theta squared. So we need to do the FOIL method and see if there's any similar problems. See if there's any similar. So that's going to be 1 plus 2 cosine theta plus cosine squared theta plus sine squared theta. And that's going to give us 2 cosine theta plus 2. I'm sorry, what? I told you I'm not doing the integral yet. I'm doing the algebra right now. When I get through, I'm going to put the square root back on. We will. I mean, right now we don't have the square root. So you do your algebra first. You do what's under the radical first. And then after you do that, then you do the. But you don't want to take the squares away because what's cosine squared plus sine squared? Okay? So you don't want to do that. Well, you can simplify that a little bit more. And this is supposed to taste like strawberry coconut.
No, it's not. It's not what's in the bottom.
Oh, this is okay.
This is what I used.
So this is actually homebrewed what?
Ginger beer.
Ginger beer. Never had that before.
Yeah. Can't drink it except that.
Well, that would be a bad thing, yes.
Everyone is making all these fruity mixed drinks. Pineapple Malibu stuff, and I'm just
No, can't do it. All right, 2 plus 2 cosine of theta. a brain bubble right now. I mean, you could put that under the radical, but I want to get something I can take the square root of. I believe I can take that as an identity. Look through your identities. I believe you can change that into 4 cosine squared of theta over 2. Using identity, I think a half angle identity. I'll put identity right here. I think you can change that into 4 cosine squared theta over 2. I think. Huh? Yeah, this is 1. And 1 plus 1 is 2. And this you can take to your half angle identities. And I think you'll get 4 cosine squared theta over 2. In other words, factor out a 2, and you get cosine theta plus 1. And what's 1 divided by 2? Well, no, that would be cosine theta over 2. I believe that will give you 4 cosine squared theta over 2. And this is what you take the derivative, the antiderivative of, or the square root of. Now you take this and plug it into that right there. So you're going to get the antiderivative. L is equal to the antiderivative from what I tell you to go to 0 to pi of 4 cosine squared theta over 2. And that's going to give you 0 pi, and what's the square root of 4? And what's the square root of cosine squared? And now you just pull out the 2. Take the antiderivative. You get 4 sine theta over 2, evaluating at 0 and pi. And I think if you do the math, I think that's your setup. And you do the math, I think you come out with 4 square units. 4 units length. Now, that's 10.3 and 10.4. We'll go over some more examples Tuesday. And we'll also look at the last 2 sections, which is kind of review over conic sections, which is parabolas and hyperbolas. So, again, this is a kind of a review section, transition section. Not a bam, 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 drill in your head, learning, like derivatives and antiderivatives. So, I guess you could say this one's kind of an easier section, easier unit. Because you're getting review and you're also getting introduction to new stuff. So it's kind of an easy section. Any questions, gripes, complaints? All right, if you got any questions, you need to see me after class. See me after class, and the rest of y'all have a good weekend. Capiche? Skype people, y'all can stay if you have any questions. The rest of y'all have a good weekend.